Hello and welcome to today's lecture of Object-Oriented Programming using Java with the paper code CS504A. Myself Shayoni Chandra, I am an Assistant Professor of Department of Computer Science and Engineering of Guru Nanak Institute of Technology. So in today's lecture, we will be discussing about the elements of object model. So the concept of object model has been previously discussed in my previous lecture. In today's lecture, we will be discussing about the elements of this object model. We know that the conceptual framework of object-oriented systems is based upon object model. Now, there are two categories of elements in an object-oriented system. The first one is major elements and the next one is minor elements. By major, we mean that if a model does not have any of these elements, it ceases to be object-oriented. And the four major elements are abstraction, encapsulation, modularity, and hierarchy. Now there are three minor elements also, which are typing, concurrency, and persistence. By minor, it is meant that these elements are useful but not indispensable part of the object model. Now let's first describe the first major element, that is abstraction. So let's describe the concept of abstraction with the help of a real life example. As we can see in the picture, there is an ATM machine and a person goes to the ATM machine to withdraw some cash. Now when a person goes to an ATM machine to withdraw some cash, that person needs to know only about the process of withdrawing the cash. But how the ATM is dispensing the cash, that person doesn't need to know at all. That means only the required information in this case is how to operate the ATM. That required information should be known by the person. But the not so required information, that is in this case how the ATM machine is dispensing the cash, that not so required information doesn't need it to be remembered by the person. So in this case, we can say that only the required information is visible to the person and the not so required information is not visible to the person. The process of visualizing the only the required information is known as data abstraction, and the not so required information is hidden from the person. That process is known as data hiding. So we can say that abstraction means to focus on the essential features of an element or object in object-oriented programming, ignoring its extraneous or accidental properties. That means the not so required information. The essential features are relative to the context in which the object is being used. Grady Bush has defined abstraction as an abstraction denotes the essential characteristics of an object that distinguish it from all other kinds of objects and thus provide crisply defined conceptual boundaries relative to the perspective of the viewer. Let's take another real life example. When a class of student is designed, the attributes roll number, name, course which the student is assigned to, and the address, all these are included, while the characteristics like pulse rate, size of the shoe of the students, these are eliminated because these details are irrelevant in the perspective of the educational institution. That means only the required information of the students that are relevant in the perspective of the educational institution, which are roll number, name, course in which the student is enrolled to, and the address of the student. These are the essential information. Only these information are visible to the educational institution, and the not so required information of a student like pulse rate, size of the shoe are hidden from the educational institution. That means enabling the educational institution to see the required information of the student is known as data abstraction, and the not so required information of a student like pulse rate, size of the shoe, which are hidden from the educational institution, are known as data hiding. Let's go to the next major element, which is encapsulation. Encapsulation, as here we can see, there is a picture of a capsule. So we all know that people take capsules in order to cure diseases. Now when we take capsules, we know that the actual medicine is there inside the capsule. The outer wrapper of the capsule is not the actual medicine. The actual medicine lies within the outside wrapper of the capsule. Here we can see the actual medicine are the green granules and the red granules. These are the actual medicine. So these actual medicines are the things that will cure the diseases. But when we take the capsule, we take the capsules using the along with the wrapper, along with the outside wrapper. Why do we do so? That's because of the reason that if the chemists sell only the inner medicine, then it may be possible that these inner medicine is can have unauthorized access, they can be wasted also. So in order to prevent the unauthorized access or the wastage of the medicines, what the manufacturers do is that they used to wrap up the inner medicines with a capsule like wrapper, so that when a people take the capsule, the inner medicine will work and cure the diseases. So basically the wrapper of the capsule, the outside wrapper of the capsule is there not to cure the diseases, but it is there to hold the inner medicines intact, so that the wastage of the inner medicine or the unauthorized access of the inner medicine can be prevented. So in order to do this, the outside wrapper of the capsule is used. Same concept if we apply to object-oriented programming is known as encapsulation. The inner granules can be considered as variables which contain the data and methods or functions. So in order to prevent the wastage of these data and methods, in order to prevent the unauthorized access of the data and methods, object-oriented programming wraps up this data and methods into a wrapper or capsule kind of thing. And this process is known as encapsulation. And this wrapper or capsule kind of thing is known as class. That means what we do in object-oriented programming is that we wrap up the data and variable together into a class in order to prevent wastage of the data and methods, or to prevent unauthorized access of the data and methods. This is the concept of encapsulation, where we bind the data and code or methods together in order to prevent unauthorized access and wastage of data. So let's move on to the next major element, which is modularity. Modularity means that the logical components of a large program can each be implemented separately. Different people can work on different classes. Each implementation task is isolated from the others. This obviously has some benefits, not just for organizing the implementation, but for fixing problems later. So we can say that modularity is the process of decomposing a problem or program into a set of modules so as to reduce the overall complexity of the problem. Grady Bush has defined modularity as: modularity is the property of a system that has been decomposed into a set of cohesive and loosely coupled modules. So we can say that modularity is intrinsically linked with encapsulation, because modularity can be visualized as a way of mapping encapsulated abstractions into real physical modules having high cohesion within the modules, and their intermodule interaction or coupling should be low. That means basically modularity is that a large program, dividing a large program into small modules so as to so that each of the modules can be implemented separately. That means the act of partitioning a program into individual components can reduce its complexity to some degree. That's why modularization is required. So it basically consists of dividing a program into modules which can be compiled separately. But these modules should have connections with the other modules also. Now, how this modularity concept is implemented in object-oriented programming languages. In object-oriented programming languages like the one we will be learning, which is Java, there is a concept of package. Now Java has packages that contains classes. We say that packages are container for classes and interfaces. So using the concept of packages, we can implement the concept of modularity. The next major element is hierarchy. As we can see in this picture, there is a hierarchy shown. As we can see in our family also, we have our parents have their parents, and we have our children. So we can say that we have inherited the properties of our grandparents through our parents. Our parents have inherited the properties of their parents, and our children have inherited the properties of us. So this is how the family hierarchy goes on. Similarly, if this concept is implemented in object-oriented programming, then it is called hierarchy in object-oriented programming. So in Grady Bush's words, hierarchy is the ranking or ordering of abstraction. Through hierarchy, a system can be made up of interrelated subsystems, which can have their own subsystems and so on until the smallest level components are reached. Hierarchy also allows code reusability. So we can say that hierarchy is really important in object-oriented programming language. Now the question is that how hierarchy is implemented in object-oriented programming. The hierarchy is implemented by using two structures. One is class structure, which is also known as is-a hierarchy, and the another one is object structure, which is also known as part of hierarchy. Now this is-a hierarchy is what? This is-a hierarchy is a hierarchical relationship in inheritance whereby from a superclass a number of subclasses may be derived which may again have subclasses and so on. For example, if we derive a class rose from a class flower, we can say that rose is a flower. That's why this name is a hierarchy. And the next one is part of hierarchy. This part of hierarchy is also a hierarchical relationship in aggregation by which a class may be composed of other classes. For example, a flower is composed of sepals, petals, stamens, and carpel. It can be said that a petal is a part of a flower. That's why this relationship is known as part of hierarchy. So, till now we have learned that hierarchy can be implemented in object-oriented programming by the concept of inheritance, where one class can inherit the properties of another class and so on, just like the family hierarchy. So those were the four major elements of the object model. Moving on to the minor elements, the first one is typing. According to the theories of abstract data type, a type is a characterization of a set of elements. In OOP, a class is visualized as a type having properties distinct from any other types. Typing is the enforcement of the notion that an object is an instance of a single class or type. It also enforces that objects of different types may not be generally interchanged and can be interchanged only in a very restricted manner if absolutely required to do so. So let's take an example to explain this in detail. Suppose there is a car class and there is an object of the car class which is Maruti cars. Suppose there is another car class which is another class, sorry, which is flower class, and it has an object, say rose. So rose is the object of the flower class. This is the object and this is the class. This card is the class, whereas Maruti cars are the objects. Now this Maruti, these cars are the objects of the car class. That means these cars should have the properties of the car class. Similarly, this rose is an object of the flower class. So this rose object should have the properties of the flower class. That means this Maruti object can never have the properties of the flower class. Similarly, the rose object can never have the properties of the car class. That means Maruti and rose, these two objects can never be interchanged, because Maruti is an object of this class and rose is an object of this class. So they can never be interchanged. This Maruti object always carry this car class properties, and this rose object will always carry this flower class properties, until and unless there is a special condition in inheritance. In case of inheritance, there is a special condition where we will see that objects can be interchanged. Until and unless we are doing that, normally two objects of two different classes cannot be interchanged. This is the property of typing. This typing property ensures that the Maruti object should always be of the car class and the rose object should always be of the flower class. They can never be interchanged. This is the typing property. But obviously there is an exception in case of inheritance where we can interchange classes, but obviously there are some stricter rules to do so. But in all other cases, no two objects of two different classes can be interchanged due to this typing property. So let's go on to the next minor element, which is concurrency. Now let's see what is concurrency. Here, as you can see that concurrency in operating systems allows performing multiple tasks or processes simultaneously. That means when a single process exists in a system, it is said that there is a single thread of control. However, most systems have multiple threads. Some are active, some are waiting for the CPU, some are suspended, and some are terminated. Systems with multiple CPUs inherently permit concurrent threads of control, but systems running on a single CPU use appropriate algorithms to give equitable CPU time to threads so as to enable concurrency. In an object-oriented environment, there are active and inactive objects. The active objects have independent threads of control that can execute concurrently with threads of other objects. The active objects synchronize with one another as well as with purely sequential objects also. So we can say that concurrency allows different objects to act at the same time. That means whenever a large program is there, we can divide the large program into small subprograms, and all those subprograms can run concurrently in a system. So this will obviously decrease the running time of the program. So this is an advantage we can say. The next one is persistence. The persistence is the last minor element of the object model. Persistence says that an object occupies a memory space and exists for a particular period of time that we already know. In traditional programming, the lifespan of an object was typically the lifespan of the execution of the program that created it. In files or databases, the object lifespan is longer than the duration of the process creating the object. This property, by which an object continues to exist even after its creator ceases to exist, is known as persistence. So, we can say that persistence saves the state and class of an object across time or space. So this is it for today's lecture. In the next lecture, we will see the relationships among the classes and objects that can exist in an object-oriented programming. Thank you.